In this video, we're going to talk about differentiation rules. Differentiation is the act of finding a derivative. So instead of doing that long process with a limit, we're going to talk about the shortcuts for finding derivatives. And the first one of these is rule number one. If f of x equals c, where c is any real number, then f prime of x equals 0. All right, so think about what the graph of f of x equals a constant it looks like. If you've got a function which is constant, its graph is a horizontal line. The one I drew, unfortunately, is not quite horizontal, but the graph of a constant function is a horizontal line. And so the derivative is what tells you the slope. Well, the slope of a horizontal line, as you know, is 0. So for instance, if I gave you f of x equals pi, and I asked you for or even pi squared, and I ask you for f prime of x, well, you know that pi is a constant. Pi squared is also a constant, and so the derivative is 0. Here's an example. Slightly more complicated than the one I just gave you, but not really. Differentiate y equals pi squared over 6. Pi squared is a constant, so is pi squared divided by 6. The derivative, dy over dx, is again 0. And let me say a little bit about notation. I'm just mixing up I'm mixing up the notations I'm using for a derivative. I want you to be accustomed to all of them. All right, rule number 2 is one of the most important rules, and one that you'll probably remember long after you've forgotten a lot of the others. It says that if f of x equals x to the r, where r is any real number, then f prime of x is equal to r times x to the r minus 1 power. So what you do, and the power has to be a real number, it has to be a constant, so x to a constant power. What you do is you take that constant, bring it down to the front, and you multiply, and then you subtract 1 from the power. And this rule also applies only when the function looks like this. It has to be x to a power. Nothing else in there, or there will be other rules that have to be used as well. All right, so here's an example. Y equals x squared. Y prime, remember, you bring the power down, and then you subtract 1 from the power, and so we've got 2 times x to the first, which I'm going to write as 2x. By the way, you may want to pause the video right after I present a problem and before I work it, and you may want to work it yourself. So here is number 2, y equals the cube root of x. This is not really written in the format that we need yet. It needs to be x to a power. So the way to rewrite the cube root of x is as x to the 1/3. Now the derivative, dy dx, would be 1/3 x to the 1/3 minus 1, but we're going to need a common denominator, so I'm going to write that as minus 3/3, and that's 1/3 x to the minus 2/3. And I would like for you to get in the practice of writing negative exponents, or rewriting functions with expressions with negative exponents, because I think it'll be better for you in the long run. So I'm going to write that as 1/3 x to the 2/3 power. All right, here's our third example. That looks like 1/x to the 6th to me. We need to rewrite this before we differentiate. So I rewrote it as x to the minus 6. Now it's in the form of x to a power. And then g prime of x would be negative 6x to the negative 6 minus 1, which is negative 6x to the minus 7. And again, I think it would be a good idea for you to rewrite that as negative 6x to the 7th. Rule number 3, the sum and difference rule. If y equals f of x plus or minus g of x, then y prime is what you would hope it would be. It's f prime of x plus or minus g prime of x. You just differentiate the two terms, or ever how many functions there are, independently, and then you add or subtract them. So let's take a look at this example. We've got f of x equals x cubed minus x squared plus x minus 5. So the derivative is 3x squared minus 2x to the first. I'm going to write that as just minus 2x. Now what about this x to the 1 power? Well, yes, it's x to the 1 power, isn't it? So that would be plus 1 x to the 0 power, and then minus 5, the derivative of the minus 5 would be minus 0. So I'm going to rewrite that as 3x squared minus 2x plus 1. We're going to interpret x to the 0 as 1, and so 1 times 1 is 1. Rule number 4. If y equals sine x, then y prime equals cosine x. Pretty easy to remember. If y equals cosine x, then y prime equals negative sine of x. That's a little bit less easy to remember. So let's combine rule 4 with some other rules and see what happens here. So you're asked to differentiate. Remember, that means find the derivative of f of x equals x to the 5th minus sine x plus cosine x. I think I'll use the Leibniz notation for the derivative this time. The derivative of f of x with respect to x is 5x to the 4th minus cosine of x minus sine of x and then finally rule number 6, or better yet, rule number 5 says if y equals a constant k times f of x, then y prime equals k times f prime of x. So here is an example, and let's get rid of this term because it's just that's a glitch. That's a copy of this term, and I think I just got overeager in my cutting and pasting. So what this rule says is that if you've got a constant times a function, you just bring the constant along. The k just comes along. You don't differentiate that and make its derivative 0. You just bring the constant along and multiply it by the derivative of the function. So in this case, the derivative, f prime of x, would be 7 times the derivative of x to the 5th, which is 5x to the 4th, minus 8. You might remember from before that the derivative of x is 1. And you know, I actually should have rewritten this term before differentiating it. So I'm going to do that right now. I'm going to rewrite that as 5/9 x to the minus 11. The coefficient here is 5 over 9, and so I'm just going to leave that as 5 over 9. I'm not going to try to move the 9. That would only make things more complicated, and it increases your chance of making a mistake. So I'm moving the x up like that and rewriting it as 5/9 x to the minus 11. All right, so we're going to have as the derivative this time is 5/9, and then that would be minus 11 times x to the, what would that be, minus 12. And I'm running out of room, plus minus 2 cosine x, right? Minus 2, and then the derivative of the sine x is cosine x. Now let's clean this up a little bit and see what we get. So 7 times 5 is 35. And we've got x to the 4th. And we've got minus 8. And let's see, I think that's minus 55 over 9. And I'm going to put that x to the 12th down there in the denominator. And let's see, we've got minus 2 cosine x.